Today we're going to talk about polynomials and rational inequalities. We're going to solve and graph these polynomials and inequalities in one variable. We have two methods to solve these. One is to find the zeros and use a sign analysis. Another way to do it is to use your graphing calculator. So first of all, we're going to do a sign analysis. We take our polynomial, which is x squared plus x minus 6 is greater than 0. There's my polynomial that's an inequality. And we're going to factor that. And we know when we factor that, that factors into x plus 3 times the quantity x minus 2 is greater than 0. And now we want to find the zeros, or the roots, or the solutions, the zeros of it, basically. X is equal to negative 3, because x plus 3 is equal to 0. Solve that. X minus 2 is equal to 0. Solve that, you get x is equal to 2. So there are my zeros of that polynomial. We will graph it on a number line. We'll have open circles because it's a greater than inequality. Now that number line is divided into three equal parts, or three parts, they're not equal, but three parts. We are going to check any number in each part. So pick any number that is less than 3. Let's say, or negative 3, sorry. Let's say negative 4, because negative 4 is less than negative 3. And then we're going to check the sign of that inequality. So if I plug in a negative 4 for my x, if I plug it into the first, I have a negative, and I don't even need to know what number it is. If I plug it in the second, I'll have a negative. A negative times a negative is equal to a positive. Is a positive number greater than 0? That is true. So it works for anything over here. Pick another number. Now between negative 3 and 2. A real easy number is 0. So plug in 0. If I plug in 0, I get a positive number and a negative number. If I multiply a positive and a negative, I have a negative. A negative number is not greater than 0, so that's false. Now pick something greater than 2. Let's say 3. When I plug that in, I get a positive and a positive, which is equal to positive, and it's true. So there is a graph of my solution. And my solution then would be negative infinity to 3, or negative 3, union 2 to infinity. That would make that inequality a true statement. If I picked anything from negative infinity to negative 3, or anything from 2 to infinity, not including 2 and negative 3, that makes the solution to that inequality, or makes that inequality true. The next one, next example. Polynomial, let's factor it. Find the zeros. X squared plus 4 factors into x plus 2, x minus 2. And x plus minus 1 quantity squared is already factored. So there it is. Find the zeros. The zeros will be x is equal to 2. X is equal to negative 2, or x is equal to 1. So those are my zeros. Again, number line. Now it's less than or equal to, so they are solid circles at negative 2, 1, and 0. Now let's choose something from negative infinity to negative 2, see if it's true. Negative 2 to 1, 1 to 2, and 2 to infinity. So let's say negative 3. If I plug in a negative 3, I'll have a negative times a negative. Anything squared is a positive, so that'll be a positive. So if I multiply all that together, I have a positive. Is a positive number less than or equal to 0? Nope, false. Now let's pick something somewhere in there. Let's say 0. Negative, positive, positive gives me a negative. A negative number is less than or equal to 0, so that's true. Pick something here. Let's say 1.5. If I plug in 1.5 there, I have a negative, a positive, a positive. That gives me a negative. That's also true. So it was true here. It's true there. What about something greater than 2? Let's say 3. Plug in a 3. Positive, positive, positive. Is a positive less than or equal to 0? That's false. So here is a graph of my solution. In interval notation, my solution would be negative 2 to positive 2. And it includes all those numbers because that is a closed circle. So it includes all those from negative 2, the interval from negative 2 to 2. Next one. Now I don't have anything greater than or equal to 0. So what I have to do is I have to get it to be 0 on the one side. So what I do is I multiply the x plus 3 quantity squared, and I get x squared plus 6x plus 9 is greater than 9. And then I subtract 9 from each side, and then I have x squared plus 6x is greater than 0. And then I'm going to factor that. Factor out an x. X times x plus 6 is greater than 0. So my zeros will be 0 because x is equal to 0. X plus 6 is equal to 0, so x is equal to negative 6. So my zeros are negative 6 and 0, both open circles. And do the same thing like we've been doing before. Pick a point. Let's say negative 7. When I pick negative 7 and plug it in here, I have a negative times a negative, which gives me a positive. Is a positive number greater than 0? That is true. So it's true for negative 7. Pick something between 0 and negative 6. Let's say negative 1. I'll have a negative and a positive, which gives me a negative number. Is a negative number greater than 0? That's false. Pick something from 0 to infinity. Let's say number 1. Plug in a 1, and I have a positive times a positive, which equals a positive. Is a positive number greater than 0? That is true. So let me hide it. Graph it. And now that I look at the graph, hopefully you can read right from the graph what the solution is. The solution will be from negative infinity to negative 6, union 0 to infinity. Okay? So there is my solution. Tomorrow in class, we will be doing this section 1-7, 1 through 41 odd.